Good morning, good afternoon, and good evening. Welcome to the Crazy Hat Chemist. So here we are with another video. Today's video is what? How to name binary covalent compounds worksheet. So, how to name binary covalent compounds. So what we're going to do is we're going to go over the set of rules that is necessary for naming binary covalent compounds, and then we are going to give a number of examples on the backside. So please pay attention to the rules. I know that some of you want to rush forward and go right to the problems themselves, but if you really want to know how to do the problems, you actually need to follow the rules. So without further ado, let's get on through the rules. So here we go. A definition of a binary covalent compound. Number one, first, in order to discover what a binary covalent compound is, we are going to first break down the word. A. The word binary has the prefix of bi, which is an associated meaning of two. Therefore, a binary compound is one composed of two elements. B. The word covalent in chemistry has the meaning that electrons are being shared between the atoms that are bonded together. C. There will be one more addition to this definition. That is, both atoms must be nonmetals. D. Therefore, a binary covalent compound is when two metals are bonded such that they share the electrons between them. All right, fantastic. Hopefully that worked out well for you for a quick little definition. All right. Rules for naming binary covalent compounds. Number one, prefixes are used to denote the number of atoms of each of the two elements. These are the first 10 prefixes. And in this particular class, we're not going to be doing anything more than 10. You can do more than 10, but for this particular class, I'm just focusing on the brief introduction of binary covalent compounds in a entry-level general chemistry course. Mono is for one, di for two, tri for three, tetra for four, penta for five, hexa for six, hepta for seven, octa for eight, nona for nine, deca for 10. So real quickly, like mononucleosis, right? That's one. It's a one-celled organism. And there's di and bi for two. So hopefully that works for you. Like a like tricycle for three, that has three wheels. Tetris, the game Tetris, which was invented by, I think, a Russian. That's for four blocks in a row, like the pentagon. And after tetra, everything that is after tetra, that is penta, hexa, hepta, octa, nona, deca, are always dealing with the shapes of the geometric figures, like a pentagon, a hexagon, a heptagon, an octagon, a nonagon, and a decagon. So penta for the Pentagon, that building in Washington, D.C., hexa for six, hepta for seven, octa, like an octopus, for eight, that has eight arms, and nona for nine, and of course a decagon for 10. All right. So we're going to scroll this on up here and we're going to continue with our set of rules for naming binary covalent compounds. The second part of this rule here, rules, the first element is always the least electronegative. That is the furthest from fluorine in terms of distance on the periodic table. You're going to write the element name that is associated with that element from the periodic table. If there is only one of that element, then do not use a prefix. If there is more than one of that element, then use the appropriate prefix. As seen above, these are the prefixes right here. If that element begins with a vowel and the prefix begins with either an A or an O, then the A or the O of the prefix is dropped. I'll show you some examples of that. Number three, the second element written is always the most electronegative, that is closest to fluorine in terms of distance on the periodic table. Write the element name that is associated with that name of that element on the periodic table. The use of a prefix is always necessary with the second element. If the element begins with a vowel and the prefix begins with either an A or an O, then the A or the O of the prefix is dropped. The use of a suffix, IDE, is always required on the second element. Okay, so I'm going to give you some examples that follow these rules right here. It's very critical that you follow and pay attention to these rules before you kind of flip and carry on. Okay, so what we're going to do is we're going to scroll this sheet of paper up and we're going to do some example problems here. Here we go, example problems. Perfect. Getting this all set up here. Hey, before we do these example problems, I'm going to do a little advertisement by our sponsor. Today's sponsor for today's video is none other than the Crazy Hat Chemist. I'm always looking for more sponsors, so if you know of someone who wants to sponsor my videos, I'd greatly appreciate that. Just let me know. Shoot me an email. Here we go. Some example problems. Name the compound CO. The first element is carbon, of which there is only one of that element. Therefore, no prefix is used on the word carbon. The second element is oxygen, of which there is only one of that element. Therefore, the prefix for one is used. That prefix is mono, but oxygen begins with a vowel, so the final O in the mono is dropped, and the suffix IDE is added to the end of the word. This gives the word monoxide. Combining both words to give the proper name of CO as carbon monoxide. Awesome. Name B. Name the compound CO2. The first element is carbon, of which there is only one of that element. Therefore, no prefix is used on the word carbon. II. The second element is oxygen, of which there are two atoms of that element. Therefore, the prefix for two is used. That prefix is di. And the suffix IDE is added to the end of that word. This gives the word dioxide. Combining both words to give the proper name of CO2 as carbon dioxide. Letter C, third example. Name the compound N2O5. The first element is nitrogen, of which there are two atoms of that element. Therefore, the prefix di is used to give the word dinitrogen. Di is for the word is the prefix for two. The second element is oxygen, of which there are five atoms of that element. Therefore, the prefix for five is used. That prefix is penta. But oxygen begins with a vowel, so the final A in penta is dropped, and the suffix IDE is added at the end of the word. This gives the word pentoxide, not pentaoxide, but pentoxide. Combining both words to give the proper name for N2O5 as dinitrogen pentoxide. All right, fantastic. All right, so what we're going to do is we're going to flip this sheet of paper over, and from there, we're going to do a number of examples. Okay, so here we go. All right, so let's see. You are watching the Crazy Hat Chemist, so hopefully you are following along. All right, so again, just a real quick here. I am hoping that you are watching the Crazy Hat Chemist. Word from our sponsor. Please watch the rules that I previously mentioned. Just don't jump into these problems right away, because then you're not going to know really what's happening. So if you really want to know what's going on, then you need to watch the beginning part of this video, not just this part. I guarantee you, you'll do much better and have a much greater understanding. Okay, let's pull these away. All right, so our first one here is we're going to name the following compounds. We have a nitrogen, we have an oxygen. So how many nitrogens are there? Well, there is one nitrogen because there's no number there. So the word for N is nitrogen. And then how many oxygens are there? Well, there's two of them. And the prefix for two is di. So that's di. And then oxygen, but it has an IDE ending on it. So that's oxide. So it's dioxide. Okay, I'm going to highlight that all of these will have an IDE ending on them. Okay, and just to make sure, if we jump right down to the bottom right here, the opposite of naming a compound occurs when the name is given and one has to derive the compound formula as in the problems below. The second element has the word IDE at the end. So this is just a characteristic of these binary covalent compounds. So I'm just highlighting that for all of them so that you understand that. So make sure that you have the IDE ending, okay? And then you are always using a prefix for the second element. So you should see that there's a prefix for every one of the second elements, and that is essential here on this. Is there a prefix for the first one? Only when there is more than one. But there's always a prefix for the second element. Hopefully you see that right there. And I'll try to remain with that same pattern. Okay, the next one is CCl4, and how many carbons are there? There's one carbon. So if there's only one for the first element, you just write the element name, that is carbon, without a prefix. You always use a prefix on the second element, and 4 is tetra. So tetra. And then that's chlorine, and it will have an IDE ending on it, so that's chloride. Okay, the second element always has an IDE ending, and of course, the prefix for the second element is always there as well. The next one here is phosphorus, but there are 3 phosphorus here. So that is triphosphorus. Spelling is rather easy. The spelling is rather easy because, of course, you just need to look on your periodic table phosphorus, right? And you should be able to get phosphorus. That's right there. Okay. And then it's how many oxygens? That's 6. So that's hex. So the prefix for 6 is hexa. Okay. And then it's oxide. Now you notice that this second element, oxygen, starts with a vowel. And we have a vowel right here with hexa with an A. So we're going to cross off this A. So we're going to have hex oxide. Notice that it will also have an IDE ending, and we did chop off the A for the hexa. We always chop off the A or the O if it is a prefix that has an A or an O, and there is a vowel on the second element. Okay, the next one here is number 4, and that's a sulfur. How many sulfurs? Just one. So you do not use a prefix, so that's just sulfur. And then the second element always has a prefix, and that is tri. So tri for 3, oxide. Again, I will have a ending of an IDE and always a prefix on the second element. Number 5. Number 5 is nitrogen, but how many nitrogens do you have? 3 of them. So that is tri-nitrogen. Okay, so I'm using a prefix there because there are 3. And then oxygen becomes oxide, but there are how many? 7. And you always use a prefix on the second element. So that's hepta. And notice that oxygen starts with a vowel. Hepta ends in an A. So I'm going to cross off the A on hepta, and I'm going to just have hept oxide. So I'm going to highlight that IDE ending again, because it will always have an IDE ending. And of course, there is my prefix. Okay, we're halfway done with naming these compounds. Let's do the second half of the naming on this sheet of paper here. All right. This next one here, number 6, how many silicones are there? There's 1. So that's silicone. Okay, and then there are 4 of these, and 4 is tetra. And this is hydrogen, so that becomes hydride. Again, that ending prefix is an IDE. Okay. All right, the next one here has 5 nitrogens, so that's penta. Penta nitrogen. Underline this prefix. We have a penta here because there's more than one. And then N is nona. Okay, and oxygen begins with a O, a vowel, and nona ends with an A. So I'm going to cross off the A, so it's going to be non-oxide. I'll highlight that IDE ending again here, and then underline that prefix here for that second element, which is always the case. Then we have phosphorus, but we have 6 of them. So that is hexa. Hexa phosphorus. Excellent. And then we have 10, and that's deca fluoride. And again, I'm going to highlight that IDE ending, and we will always have a prefix for the second element. All right, the next one, we have a sulfur again, and there's 4 of them, so that's tetra. So tetra sulfur. So hexa and tetra sulfur. And 8, that's octa fluoride. Not so bad with those IDE endings at the end and the prefix for the second element always. The next one here, we have carbon, and how many carbons? That's 2, so that's dicarbon. Just underline that. And so the second element, we always use a prefix, and that is going to be trisulfide. Again, highlighting that ending here and underlining that prefix. Okay, so to real quickly recap, you should see that there's a pattern. That pattern is the second element always has an IDE ending. The second element always has a prefix. The first element has a prefix if there's more than one. And there's a couple of rules with 2 vowels together with the A's and the O's. So make sure you're paying attention to those. All right, the next set, what we're going to do here is we're going to do the opposite of what we just did, and we are going to write down the formula of the names. This, to me, is actually much easier, and here's how we're going to do this. We're going to look at the 2 elements of which we have. So we have a phosphorus and a chlorine. So I'm going to write phosphorus and chlorine right there like that. And then right after that, then I'm going to write down how many I have. So phosphorus, there's only 1, so there's an imaginary 1 here. I don't actually write imaginary ones, okay, but there's an imaginary 1 right there. So it's going to really be PCl, and there's a 1, but we don't write 1, so we're not going to write that 1 right there. And we always write a prefix for the second one, and how many? That's a tri, and that is a 3. So it's PCl3. Perfect. One of the most common mistakes is that I have taught ionic compound naming, and that's when you take the bull by the horns and flip and bring it down or flip and bring it up, but you do not do that with binary covalent compounds. So that's why it's sulfur, sulfur, fluoride, fluoride. How many sulfurs? There's no prefix, so that means there's only 1. And then how many fluorides? There's hexa, and that is 6. So 6. Simple as that. Then there's nitrogen and oxide. Nitrogen and oxide. How many nitrogens? Well, dinitrogen, that's 2 nitrogens. Hex oxide, and that's 6 right there. Perfect. There's carbon and oxide. So carbon and oxide. Tetracarbon, so that's 4 carbons, and octa, that's 8. Now here is a note, which you don't get this if you follow the rules on the front, but you cannot reduce any of these. So notice this 2 and a 6. This cannot be NO3. That's an entirely different name. That's nitrogen trioxide. That's different than dinitrogen hexoxide. Same with C4O8, that cannot be reduced to CO2. Carbon dioxide and tetracarbon octoxide are completely different compounds, behave in completely different ways chemically, etc. The next one is nitrogen and oxide. So nitrogen and oxide, and tri, so that's a 3. Hept, that's a 7. So this part, I think, is really simple here. The next one is pentaphosphorus. So we got phosphorus oxide, oxide like that. Penta is for 5. There's our 5. And dec oxide, that's for 10. Again, that's not something that we can reduce. So you cannot reduce any of these binary covalent compounds. The next one is silicone, that's Si, and chlorine, that's Cl. How many silicones? There's no prefix on that, so there's only one. Tri-silicone, and that's a 3 right there like that. Hey, did you know that you are watching The Crazy Hat Chemist? Did you read and did you actually follow the beginning part of this video and not just start right here? I hope you didn't just start right here, because that is the wrong thing to do. You need to be watching the rules and making sure that you understand the rules so that you can actually do these problems on your own, because that is the whole idea here. I'm all about you learning the chemistry, not that fluffy chemistry stuff. Okay, going back to the video. We have sulfur and oxygen, so that's sulfur and oxygen. How many sulfurs? It does have a prefix, so that's di is for 2 and tri is for 3. Okay, so it's S2O3. The next one is sulfur tetroxide, so that's sulfur and oxide again, sulfur and oxide. Is there a prefix on the first one? No, but there is for tetra, and that is 4. So we have SO4. And then a very final last one is trinitrogen pentachloride. So nitrogen and chloride, nitrogen and chloride. Tri, that's 3. Penta, that's for 5. So as long as you know your prefixes, then you are rocking and rolling and good to go. All right. That's a wrap for this video. I hope you learned a lot, and please like and subscribe. I appreciate the business, and thank you very much. And I'm going to see you next time. I am the Crazy Hat Chemist, and this is the right place to watch the videos that make you learn chemistry. I'll see you later. Bye for now.